Hi, continuing the DSL topic, I would like to show you how to expose a REST API using Spring Boot 3, Kotlin, router and bean definition DSL. In my previous article and video, I showed you how we can get rid of annotations like REST controller, request mapping, query param and path variable. And this time, I would like to show you how to get rid of annotations related to bean definitions like component, service, etc. So, without any further ado, let's get to work. So, as the first step, let's generate a new Spring Boot 3 project, and to do so, we will use the Spring Initializer page. So firstly, let's open up our favorite web browser and navigate to start.spring.io. On this page, we have the possibility to configure the project. So firstly, I will select the Gradle with Kotlin. Nextly, the language will be Kotlin as well. And when it comes to the version, we will go with 3.04. When it comes to the project metadata, you can specify whatever values you would like to. I will go with coder_c. When it comes to the artifact, I will specify Kotlin DSL, for example, and I will get rid of the description. Fortunately, in order to expose a REST API with Kotlin DSL, we don't have to add any dependencies except the Spring Web. So let me click right here, Spring Web, and select this one. Lastly, let's click Generate, and this way the zip file is downloaded. So let me click on that, extract all, hit extract, and wonderful. As the next step, let's open up IntelliJ, open, and we will have to find the project in the downloads. We can see right here we have the Kotlin DSL, and let's click on the folder with a small black icon near to it. Hit OK, and now this step can take a while. Gradle will fetch the necessary dependencies and basically build the project. So let's wait a second until everything is done. When we see that Gradle finished, we can navigate to the main package, Kotlin, and let's create a new package. I will call it model. New package, model. Right here, I would like to put 3 data classes: user, user DTO, and error response. The first one will normally be used to communicate and exchange the data with the database. User DTO, on the other hand, will be used to serialize and deserialize JSON payloads. And lastly, the error response will be used to manually generate a payload when any error happens in our application. So let's start with the user, new Kotlin class. Let's scroll to the data class and specify user. I would like this class to have 4 fields: ID, email, name and age, val ID of a long type, nullable with a default value set. Nextly, name, which will be string, email, a string as well, and lastly the age, integer value, integer. Ctrl+Alt+L, format is done. So nextly, let's introduce the user DTO, data class, user DTO, and this class will have 3 fields: only email, name and age. Val email, val name, and lastly age, integer value as well. So as the last step, let's introduce error response the same way. New Kotlin data class, error response. And I would like this to contain only 1 field, and this will be message. Message of a string value. Ctrl+Alt+L. Wonderful. As the next step, we will take care of the repository layer. So firstly, I will create a repository package. New package called repository. As the first thing I would like to create here will be the user repository interface, which will contain the definitions for all the functions we would like to expose. So right here, Kotlin class/file, select the interface, and let's name it user repository. Wonderful. Firstly, let's define a function to create a new user, fun create, and this will have only one parameter of a user type user, and let's select the correct one. Nextly, let's define a function to fetch all users and call it find all, no parameters, and a response type will be a list of users. Following, let's create find by ID, fun find by ID. This will have one parameter of a long type, and as a response, I would like the user or null to be returned. Following, the update by ID, fun update by ID. It will take the ID of a long type and additionally a user of a user type, and as a response I would like to get the nullable user as well in case that nothing is found. Lastly, let's insert the delete by ID, fun delete by ID, and of course this will take the identifier and we don't have to return here anything. Ctrl+Alt+L, wonderful. And although oftentimes I skip this part for the simplicity of my tutorials, in real life scenarios we should consider using interfaces rather than the implementations, and later you will see why. Let me close this pop-up. And nextly, let's add a user CRUD repository, which will be an example implementation. So let me click on the repository, new Kotlin class, and name it user CRUD repository. Wonderful. And this class will implement the user repository interface, user repository. Let's open up. With Ctrl+E, we can automatically insert all of the functions we have declared in our interface. And additionally, I would like this user CRUD repository to be just a dummy in-memory database. So let's specify a data source as a constructor parameter right here, which we'll later inject using Spring. Val data source, and this will be a mutable map of a long type for the identifiers and users for given identifier. Ctrl+Alt+L. Wonderful. Let's insert a new line right here and let's start implementing our first function, create. So let me get rid of that. And firstly, I would like to figure out the last identifier. So val last ID will be this data source, keys, and max. This way, we'll get the biggest identifier, which we already have in our, let's say, database, in-memory database. Val incremented ID equals last ID plus 1. Let's now update the user, so we'll simply get the user, val updated user equals user, copy, and let's replace the ID equals incremented ID. Nextly, let's simply insert that to our map. So this data source, incremented ID, and I will put updated user. So we will simply insert the user to our map. And lastly, return user. As we can see, the code does not compile. So let's click Alt plus Enter, and we can change the return type of enclosing function. Nevertheless, I forgot to do that. So let's get back to repository and right here specify that it returns a user instance. Let's get back. We can see that now compiler is happy. So as the next step, let's implement find all equals this data source, values this time, and simply invoke the toList function, and we'll get a list of all users in our map. Nextly, let's find by ID, so again equals this data source, and we'll try to get the user by identifier. Of course, this may return a user or otherwise we'll get a null value. Nextly, let's do the update by ID, so again equals this data source, by ID. So we are doing exactly the same. Technically, we could invoke the find by ID. And if the value is not null, let right here found user. And now, firstly, let's update the user. So val updated user equals, and for our user, I would like to update the identifier, copy ID, and for example, we can go with found user ID. Wonderful. Nextly, let's replace the value in a map. So this data source by ID, I would like to set the value to updated, put the updated user. And lastly, we would like to return the instance of our user, so simply specify the updated user. We can see that everything is okay now. And the last one, delete by ID, we'll simply use the remove function on our map. This data source remove, and I would like to remove the item under the ID key. Wonderful. Again, as we can see, this is just a dummy in-memory database which will be operating on a data source, which now I would like to implement. So we can create a new package. I'll put that in config, but please feel free to do it whatever you want. Nextly, let's introduce a new object, new Kotlin class /file, and right here we have to find the object. I will call it data source. So our data source will contain two maps. One we will call the dev data source and the second one will be a prod data source. But in real life scenarios, instead of two maps implementations, we would rather have a few implementations of user repository. For example, one in memory, which could be used for local and for example for testing, and the second real one responsible for database connection. Either way, the purpose of this tutorial is to learn a bit more about Kotlin with bin definition DSL, so this setup will be useful in our considerations. With that being said, let's introduce the dev data source. So val dev data source. This will be mutable map long user, and let's define it mutable map of, and right here I would like to introduce first user to user, and ID will be 1L. The next one name, so name 1 for example. Email will be email1@gmail.com. Nextly, let's go with some age 24. Let's add a colon, and with Ctrl+D we can duplicate lines in IntelliJ. So Ctrl+D, for example, let's take 5 values and let's start changing. 43, 30 for example, 23 and 20. When it comes to the emails, let's do exactly the same. 5. Name will be also generic 3, 2. The identifier will be updated. And lastly, we have to update the keys related to our users. Let's select this data source, Ctrl+D once again, and let's name it a prod data source. This time I will simply prod name 1, prod name 2, prod name 3, prod name 4, and prod name 5. When it comes to the emails, I would like to show you an interesting shortcut. In order to write at the same time in multiple lines, you can quickly hit Ctrl and keep it pressed. So 1, 2, and now with arrows you can define which lines you would like to work with. Prod rider. This is really interesting shortcut and I use it a lot, for example, in cases like that. So at this point we have everything we need to work with a dummy data source and we can start implementing router. When working with Kotlin root DSL, this will take 2 steps. The first one will be to implement a user handler, which will be a counterpart for a standard controller, and the second one will be to define the actual routes. So let's start by adding a new package, and call it handler. Following, let's add a class called user handler, user handler. So again, in this tutorial, we will implement a REST API without adding any annotation. So the only thing here I would like to do will be define a constructor with one parameter. Private val user repository, and let's make use of our interface. As I mentioned previously, interfaces used instead of implementations allow us to easily adjust this behavior and to provide our custom implementations on the fly, for example for testing or simply when defining beans with Spring. So as the next step, I'll provide a couple functions responsible for handling requests. Let's start with the first one and call it create user. Fun, create user. It will have one parameter, request, of server request type. As a response, we will go with server response. Wonderful. Firstly, we would like to read the request body, which user will send us as a JSON. So val user request equals request body, and right here we can specify the type which we would like to instantiate. So this will be user DTO and reference to the type. Wonderful. The next thing I would like to introduce a new variable, val created user response, and this will be equal to user repository create, and for the user we will have to provide the user instance. So what we can do now will be introducing two extension functions which will be useful to convert user DTOs to user instances and user instances to user DTOs. So let me get out of the user handler, private function user DTO to model, and as an instance I would like to return the user instance. Let's create a new instance, simply invoking constructor. Name will be equal to this name, email similarly, this email, age, this age. That's all we need. Nextly, let's introduce the other way, so user to DTO, private fun user to DTO, and this will return user DTO equals user DTO, and just like previously, name equals this name, email, this email, and age, this age. With that done, we can get back to our function user, and right here I would like the user request to be converted simply to model. And now in order to get the response, we can simply invoke to DTO. Ctrl+Alt-L, wonderful. And finally, let's return 200 OK with the payload. So return server response, OK, and body will be simply created user response. So each time the user is created, the API will return the created user response as a payload and 200 OK status code. Following, let's add find all users, fun, find all users, and similarly request will be the server request, response will be server response, val users responses equals users repository, find all. We are getting the list of users, so what we can do will be simply invoke them up, and for user to DTO. Wonderful. The last step, return server response, OK, and the body will be users responses. Nextly, let's find the user by ID. Fun, find user by ID, parameter of the request, and response type server response. Nothing changes here. The only thing I would like to do here will be to get the identifier as a path variable. So what we will have to do will be introducing a new variable, and let's call it ID. On the request, we can invoke the path variable function and specify the name we would like to read, and this will be ID in our case. Nevertheless, we don't have any possibility to parameterize what type we would like this path variable to be, and we have to do it manually. So let's invoke to long or null, and if the value is null, so we weren't able to successfully convert the string into long, then I would like to return a bad request response. To do so, let's go with LVS operator, return, and I would like the server response to be bad request, and as a body, we will create simply a new error response, which we've already implemented with invalid ID message. And what we can do here will be extracting that, because I will be using that later as well. So we can select our code, Ctrl-Alt-M, and let's name this function, but request response. Wonderful. Let's get back right here. We can format this a bit, Ctrl-Alt-L. We can hit Alt-Enter and specify the return type explicitly, and we can introduce one parameter, message for example, and the message will be a string type, and we can provide it right here. Nextly, we will simply try to find the user, so val user response equals repository find by ID. Nevertheless, this will be a nullable invocation to DTO, so we will either get a null or a DTO. So lastly, if the user is found, I would like 200 OK to be returned, or otherwise I would like the 404 not found. Return user response, and right here let operator response server response, OK, and body will be response. Nevertheless, if this is not the case, then we will simply return the not found response. So server response not found, and this time simply invoke build. Ctrl+Alt-L. We can also extract this one, Ctrl-Alt-M, not found response. Let's navigate to this function, and again Alt+Enter, specify the return type explicitly, and simply move this line to another line, and wonderful. And let's add a new handler to update users. So let me scroll up a bit, fun, update user by ID, request, server request response, server response. And similarly, we can copy paste the logic responsible for getting the ID from path variable. So this one, Ctrl+C, and wonderful. The next thing we would like to do will be to fetch the user request, val user request equals request body, and again user DTO, and specify the type reference. Nextly, let's get the updated user, val updated user response equals user repository. Let's invoke the appropriate update function, and this requires us to pass two arguments, ID, and the second one will be user, so we have to take our user request and convert it to model reusing our extension function. If everything is good, then simply to DTO, and this way we'll get the user response. Lastly, let's simply return the value, so if the updated user response is not null, then response, I would like to return 200 OK. Response, OK, and body will be the response. Anyway, if this is not the case, then simply not found response. Ctrl+Alt-L, wonderful. So we have only one handler remaining, and let's implement it. Function delete user by ID, request, and response, just like previously. Again, we can reuse the logic responsible for fetching the identifier, and the only thing we will have to do here will be invoke the appropriate function, user repository delete by ID, ID, it does not return any value, so what I would like to return here will be 204 no content. Return server response, no content, and the build function. Ctrl+Alt+L, wonderful. So as we can see in our handler, we don't need any annotations. Instead, we are dealing with server requests and server response. This approach additionally gives us a good possibility to, instead of throwing exceptions and returning this way as status codes to users, to handle that manually, just like we did with pad request response or not found response. And if you would like to learn more about it, then I redirect you to my previous video and article. But for now, let's create a new class inside the config package and define the way Spring should handle requests. So let me click on config, right mouse button, new, and introduce a file called routes. We don't need any class. Right here, I will define an app router function, fun app router, which as an argument will take the user handler of the type user handler equals. And right now, when working with Spring Boot or Spring Webflux, we will use the router. When working with coroutines, then there is another variant, which is corouter. Inside this function, we can define the structure of our API. With the usage of nest functions, we have a great possibility to manage all the routes in one place and also structure it in a neat and readable manner. So let me show you an example. /API nest. Then I would like to define a new segment, users. Right here, I would like to nest, and as we can see, all the requests going to /API/users will be handled by handlers defined here. So let's start with the first one, which will be a counterpart for post mapping annotation. Post. I don't have to provide any pattern because I would like the /API/users to be the desired URL, so I will only use the user handler and define the reference to appropriate function. Just like this, let's go with get, and here invoke find all user handler, find all users. And although I am using function references, you can do the same by simply specifying the invocation with request, user handler, find all users, and forward the request. So basically, I prefer this approach, but of course, if you feel that this is more readable to you, then please use this approach. Anyway, let's get back to work and let's specify 3 remaining endpoints. So get, and right now I'll add the pattern with path variable ID, which will use user handler find by ID. Similarly for put, the pattern will be the same /ID, and the handler will be user handler update user by ID. Lastly, let's add the delete pattern exactly the same, comma user handler delete user by ID. Ctrl+Alt+L, wonderful. And basically this is all we need when we are defining the routes. Nevertheless, we will have to define a bean later. So as the last step, let's finally switch to Kotlin bean definition DSL. I will create a new class and I will call it beansconfig. So let me click on config, new, Kotlin. And right here, I would like to add the file beansconfig, not a class. The class will be added later, but firstly, let's start defining beans. In order to do so, let's define a top level function and make use of beans. So val beans equals, and right here invoke the beans function. It's nothing else than a function which leverages the concept of type-safe builders. I will attach to the description the link to the documentation if you would like to learn a bit more about this topic. Nevertheless, for now, let's add a beansconfig class. So, class beansconfig, and we will have to implement the application context initializer interface. So application context initializer, and we have to specify the type here. We will provide the generic application context. Nextly, we can simply go with Ctrl+E, hit OK, and automatically a function was inserted. What I would like to do here, we will have to invoke the initialize function on a beans. So beans initialize and provide our application context. Let's navigate to this function and see what it does. So as we can see, it registers beans defined via DSL to the provided application context. With that done, we have to make Spring aware of our custom initializer. And when working with Spring Boot, we can do that with application properties. So the first thing, let's navigate to resources, application properties. I will rename this to application YAML, change the extension, and let's define context, initializer, wonderful, classes, and right here we have to specify where our class is placed. So coderc, Kotlin DSL, config, and beans config. Wonderful. With all of that being done, we can learn how to define beans using DSL. So as the first step, let's see how we can define the user handler and router beans and instruct Spring to auto-wire by type. So let's go to beans and let's define our first bean. This will be user handler. Bean, let's specify the type, user handler, and invoke the function. Following, I will use the callable reference in order to define the router. Bean, and right here the callable reference app router. Ctrl+Alt-L, wonderful, we have these two beans defined. Following, we can add a bean of user CRUD repository and see whether the application will start. So let me go with bean, right here, user CRUD repository, and provide the dev data source, dev data source. Ctrl+Alt-L. Now let's get to the main function. As we can see, the Spring Boot application is the only annotation we use today. Nevertheless, let's run the main function and we should see that everything is working as expected and the application should start. Wonderful. As the next step, let's see how we can define beans based on a profile set in Spring. So let me get back to beans config. And right here we have defined the dev data source. Nevertheless, let's say I would like this one to be only active when the dev profile is set and the prod data source when a prod profile is set. So what we can do now will be get rid of that, and now we can use the profile, and right here we can specify the name of the profile. So I will use dev. Inside this, we can simply define beans just like we did this above. So as we can see, the beans definition DSL allows us to manage beans in one place, which is really readable, especially compared to the approach with annotations when we have to look for them across the code base. Anyway, let's define the CRUD repository, user CRUD repository, data source, and this will be a dev data source. Let me copy that, Ctrl+C, Ctrl+V, alternatively you can use the Ctrl+D. And for the profile prod, I would like the prod data source to be used. When it comes to setting the profile, one of the easiest way is simply to add additional config in our application YAML. So let's go right here, Spring, profiles, active, and let's set dev. Ctrl+F2, Shift+F10 and rerun the application. Wonderful, the app is up and running, which indicates that the bean was configured successfully. If I change the value to dev to whatever, stop and rerun, the app should not start and we see that this is the case. Anyway, let's fix that. And now let's learn how we can explicitly specify the bean type. So again, let's get back to beans config. As I mentioned, with this approach, we instruct Spring to wire by type. we can alter that. So let me remove that. And firstly, let's define the user handler and let's add some name. So firstly, bean, it's a standard function, my handler name. Right here, I will define the bean user handler and I will use the reference to inject the value. Nextly, when defining the app router, bean app router, and let's invoke that with ref and provide the name to our handler, my handler name. When I hit Shift plus F10, the app should run successfully. Wonderful. Now when I change the name to invalid1, the app should fail, which indicates that we are wiring by explicitly specified name. Let's fix that. And nextly, let's see what exactly we can define inside a bean. So right here you can see that I have changed the name of the bean, but when we go to the function, we will see that the bean function takes plenty of parameters and makes use of default functions, a Kotlin feature, and right here we can specify many properties of our bean. For example, we can define the scope, whether it is lazy init, and whether this is primary when we are defining multiple beans of the same type. So in order, let's get back to our example. As we can see right here, we've already used the name, so I can do it this way. And let's say I would like to change the scope, equals scope, and right here I can use the provided enum, and let's say I would like this to be a prototype. So this is a good example that we can still customize our bean without the usage of any annotations. Lastly, let's see how we can read environment variables, because this is oftentimes a case when working in real-life scenarios. So we can define a custom variable, let's call it some variable, val some variable. And right here, in order to read variables, simply env system environment. And when we will see the definition, we'll see that this method returns a map of string with objects, which are simply the value of system getEnv. So this way, we can read our env variable 1 and assign it to our variable in Kotlin. To check that, let's copy the value. Right here, I'll provide a breakpoint, and let's go to the configurations and provide some environment variable. Environment variable, some value. Let's hit OK, once again OK, and this time let's rerun the debug. As we can see, the sum variable was read successfully. Again, this is a great example that bean definition DSL allows us to customize the behavior of beans a lot. For example, we can introduce all the concepts you know in Kotlin. Just like right here, we simply read the environment variable, and for example, we could define the bean based on that variable. We could perform a database call or use any concept known from Kotlin like loops or if statements to define and customize our beans. Again, I believe this is a great advantage of bean definition DSL, and although this might not be the best choice for all projects, it's still worth to be aware of that functionality. And that's all for this video about how to implement a REST API without annotations using Spring Boot 3, Kotlin bean definition, and router DSL. As a homework, your task will be to verify whether all endpoints are working as expected. And if you enjoyed the content, then please let me know in the comment section. Thank you for watching and see you in the next ones.